Hello, good evening. Here we are with one more video. This time it is regarding code. This code will discuss and describe how the pre-processing, uh, which is a pre-mining step of the data mining, has been done. We have made heavy use of pandas library and regular expression library to perform the data cleaning and scrubbing transforming operations in this code, as you will see as I explain later on. So what we do is uh, this code, the way how it has been structured is that it is going to clean, scrub, transform, integrate all the data frame that we have selected for pre for the mining stage later in the one single code. So this will be a extremely busy video presentation. So please bear with me. We use the pandas library to read the gold price.csv over here. Then we try to interrogate the columns of that CSV file. We have given it name values. The reason why we have just given it as a name values, there is no real specific, just to give some name, because it contains a string of characters of the data crawled from the website. Then we make use of that single column which contains all the crawl data in the form of string, and slowly, part by part, what we are doing over here is we are using the method string.extract with the help of the regular expression, and we are trying to extract those parts and bits and pieces and assign them to the column vectors, to which we then keep on giving the name that we desire, and thereby slowly, one column by another column, we generate a data frame from a raw uh, set of data that was extracted from the website by name values. That is what, in a nutshell, this piece of code is doing over here. Just a couple of lines to explain how that was achieved is, so if take for example data frame, we interrogate values, which is a one long string of 50 100 characters which has got string inside, which was crawled from the data frame. We call the method by dot string dot extract, and then we send in a pattern uh, of regular in a regular expression grammar, that pattern that it needs to go and find in the string, which is given by this group, so which is dot colon and few other dots inside the single inverted comma. So it goes, extracts that kind of pattern string from these values vector, and then whatever it has extracted, it assigns it to a vector by name time. So now your data frame would have a vector by a column by name time, which has got something inside, which is basically nothing but the time uh, that we have extracted, which is we know from the raw data it is in this format. Same thing here, you do with date, that you give the format of date, and it goes inside the raw strings, and it extracts that kind of a pattern and it assigns it to date. All that is assigned to this new vectors that are being generated in the data frame. They are all in the character type. So the data type here is all character, which will hardly be of use when it comes to modeling or data mining. So what we are going to do is we are going to then clean those vectors further. As you can see, one of the example over here which we have done is gold price in ounce. We have extracted, and then we have done replace and clean, and then we have converted the string or the character type to a numeric type by using the method as type float. So now it translates or it converts the character string into the numbers, which is now of a great value for our models to be able to read and do a meaningful analysis. So that is one couple of examples how we use the regular expression to extract the data and generate the data frame column by column. Same way we came to the bank stocks and the time series data that was extracted by the crawlers. In this case, it is not too much complicated because the time series that was extracted is purely numeric. Whilst in the gold, it was alphanumeric. We had table, we had the representation on the website was such that you have to write complex regular expression pattern matches to extract the type of data that we are really looking for. In time series, it was relatively easy. The interesting thing in the time series transformation was that after getting all the data cleaned and representing them from the character in the numeric type, we created new features by name day arbitrage, start arbitrage, and minute arbitrage. The reason why we did that is because the original features or the original crawl data, which is like open price, last price, high price, low price, they bring little information when it comes to tying it back to the hypothesis that we want to evaluate. So all that we are doing here, we need to remember over and over again that as we go further through the data pipeline and push the data towards the data mining step, we need to see that whatever we are producing, whatever we are transforming, whatever we are extracting, whatever we are loading, it ties back to the star schema that we discussed in our previous videos and to the hypothesis, because that is the very reason why we are even doing this entire exercise. So what we do here is that we produce more relevant features because day arbitrage allows us to know the windows um, uh, of arbitrage advantage where the trading can happen from morning to evening. Similarly, star arbitrage will allow the time when you have like when the market opens, what are the starting arbitrage advantages or disadvantages. Minute arbitrage is a bit high frequency trade uh, for the enthusiasts who are interested in high frequency trades because it gives you the arbitrage minute by minute. They have been derived not from something very complex, it is from very simple thing. We take the high price and the low price, we find the difference, which is the arbitrage, we assign it to the day arbitrage variable. Similarly, for the star arbitrage, we take the difference between the opening price of the day, so say today morning, and then we take the difference with the last price, which is yesterday evening's closing price, and then that difference is assigned to start arbitrage, and the minute arbitrage is the previous close, the last minute, and this minute and the last minute difference in the price, the buy price and the sell price. So those are the arbitrage advantages you have. They tell us a lot about the sentiment of the traders, the brokers, the investors in the market, the sentiment during day, sentiment during starting of the market, sentiment every minute. From the other perspective, if you look at it, it also gives us, apart from sentiment, it also tells us the windows that are available for hedging. So that is the significance why we transform the original features into new features that are more meaningful uh, for us to find some patterns in the time series of stocks. Eventually, once we have transformed and modified the data frame and converted them into new features, we drop the original features because they are not required anymore. Then we move on to currency exchange data frame for cleaning and scrubbing, which we get over done in the same way how we did with the rest of the data. We use pandas concat method to concact the entire data frame, and then we try to probe the is NA values. You remember last video we discussed that in the SAS enterprise miner we came across too many non-values, not a number values, missing values being coerced because of the integration, because of the juxtapositioning of the two time series and the jumbling up of the time series data. And that's why you see extremely high number of is NA values over here. But like a magic, by doing certain transformation and representing data in a particular manner, as you will see down in the code here, they would all disappear and we will get a very clean, very refined, very clean data frame. So how do we achieve that? We drop the time and unwanted columns that are bringing in the non-values. So as we discussed that integration of the gold and currency exchange data, because it is not at the same frequency as the time series data of the stocks, it has induced too many non-values noises and we will not be able to use them to our any added value for the time series analysis of the stock. So we drop them. Then from the day arbitrage, which is the 17 NA values, the missing values which have been coerced inside, we drop them by using an inverted function not NA. So we choose the only ones which are not NA and we get rid of them. And finally, all the other NA values which have come in as artifact of data integration, we take care of them by querying them and reorganizing the entire time series by grouping them by the stocks. So by grouping the entire thing by public bank, the time series grouping the entire time series of RHB Bank by RHB Bank. And the way how we do it is we arrange them by business segments, as you can see: retail and corporate banking, financial service and marketing, retail finance and insurance. Um, Once we have done that, we merge them into a separate data frames by name, integrated data frame just for bank, then for financial service as MRG underscore fin, and for insurance companies as MRG underscore ins. And we do it on date because that is the one common column against which we can join them. So that's what we do. And the end, what we do is, after doing all the hard work of cleaning, transforming and restructuring on the entire frame with huge quantity of numeric values, we extract them in the form of CSV file, because that is what we would be needing eventually to export them into any other tools that we want to do in future, like Tableau for data visualization, or exploratory data analysis, or enterprise miner for data mining. So we make use of the to underscore CSV method to extract every single data frame into a CSV format, so that we don't have to go back and forth between Python and the tools later on. So that's about uh, the pre-processing step of cleaning of the data. In a nutshell, this is how most of the cleaning of all the other data frames would be done hereafter, if any is required, which you will see anyway in the codes when in my future videos. Thank you very much for listening. Goodbye for now.